Okay. Okay. So hi everyone. My name is Liron, and thank you for accepting my session for Central Asia Oracle User Group. As you can see here on the slide, we're going to talk about design, database design, and schema design today. And as you can see, these are my contact details. I have them at the last slide as well. So feel free to contact me, to follow me on Twitter. I have LinkedIn as well. It's not here, but it's relatively easy to find me. So just feel free to reach out. So let's begin. I'll introduce myself a little bit. So first of all, I'm from Israel originally, which is the purple area here in the Middle East. And about just over 6 years ago, I moved all the way across the world to Vancouver in Canada. And this is where I live now. We are about 12 hours different. So it's 8 p.m. here. It's morning for you. So good morning if you drink coffee or something. I'm going to close the day after this session. And I've been working with Oracle databases since Oracle 7 and 1998. I've been a consultant since 2002. I have my own website, gotodba.com. There is a technical blog there, but not only, I've got all kinds of different resources there. So you're welcome to go and subscribe if you want to get some updates. I've been part of the community for quite a long time. I'm an Oracle ACE director. You can see at the bottom here, I'm also a president of the local Oracle user group here, the BCOUG for British Columbia in Canada. And I have two other initiatives. One is a podcast called Beyond Tech Skills, and you can see that on the right, the beyondtechskills.com. And that's a podcast I'm doing with Jim Suprinsky. And we are talking about the tech world, but we're not talking about technology. So we're going to talk about, we're talking about soft skills and interviews and diversity and inclusion and all kind of other stuff. It's really fun. We release an episode every 2 weeks. And if you like listening to podcasts, you can definitely subscribe with any podcast app out there. And the last thing is I'm part of the program called MESH program, and MESH stands for Mentor and Speaker Hub. And the concept of this program is to help new speakers get into tech conferences. So if you or someone you know want to speak, or not sure, but maybe wants to speak at conferences, but they don't know how to start, where to start, they need some assistance, you can definitely go to meshprogram.wordpress.com, read what we do there, read who we are, and join the program. It's completely free. It's just there because we want to get new people speaking at conferences. So we'll be happy to assist. Okay, so that's it. And let's start with the session. So the session goal today is basically to open your mind and make you think. Okay, you'll see along the way there is no right or wrong or something like that, but there are things that you need to consider and pros and cons of everything. And this is what I want to do today, just to introduce you to all kinds of different pros and cons and make you think the next time you need to actually design some tables or schema for your application. So what are the goals of schema design? By the way, I didn't say that, but you have the Q&A panel and you have the chat. Feel free to use them. I have two monitors here, so I'm looking aside all the time to check if someone writes anything. So if you have a question, if you have a comment, anything, just put it there and I'll see it pretty quickly. So what are the goals of schema design? Well, we are designing the schema, the database we're working on. What are the goals? So there are a few things. First of all, database, as we all should know, it's a box to store data and retrieve data. And if one of that is impossible to do or difficult to do, we're missing the point, right? If the application needs to do so much processing or so much, I don't know, stuff on the data just to enter it into the database, and it will be hard and it will be slow. We'll talk about performance in a minute. Then we're missing the point. We want everything to be relatively easy, and we want to be able to store data and retrieve it. If we manage to store everything, but we cannot get it because it's difficult to find the relevant piece of data we are looking for, something like that, again, we are missing the point. So first of all, we want to store and retrieve the data, be able to do that. The next thing is data integrity. Okay, if we have data in the database, we want to make sure that it's intact, that it's correct. There are no contradicting pieces of data or pieces of information, because if we have something that contradicts something else, we don't know what is correct and what is not, and that's a main problem. So we need to make sure that the data integrity is kept. Performance, obviously, if you want to insert many rows or query many rows or many users working on the database at the same time, we want it performing well. And if everything works, the data is perfect, integrity is kept, and we can store everything and retrieve everything, but we cannot, get results in a reasonable time. Again, we are missing the point. That's a bad design. And the last thing is flexibility. Okay, sometimes we want to allow some more flexibility into the database. Sometimes we don't want to allow flexibility and we want everything to be more strict. So these are the 4 major things that we need to think about with every design that we build. Okay, and it's important to understand that each application or each system has different requirements. And it can be different for storing and retrieving data, or performance, or data integrity, or flexibility, and the design should reflect that. Okay, so applications that are very flexible versus applications that are very strict, the database design will probably be different with these two. Okay, and we'll see examples for that. So what is a schema design? When we are designing a schema, what are the things that we actually have control on? So there are 4 main things, and I'm going to dive to each one in the next slide. The first one is data types and values. Next one is indexes. Next one is tables and normalization. And the last one is constraints and triggers. And with these 4, we can keep or maintain the 4 goals that we talked about in the previous slide. So let's dive into each one of them. So design your column and data. And these are examples, and these are real-life examples, not the data, but the concept. And I just want to explain, the downsides or problems in certain design or ways to design. So in this case, we have a table. We have a city in the world. We have the high temperature, date, and the temperature itself. Okay, and this is the table that I have. And as you can see, in Vancouver, where I live now, that was July 30th in 2009, and it was 34 degrees. In Tashkent, which is near your area, it was July 6th, which is actually my birthday. That's nice. 1881, that was 44 degrees. And Tel Aviv was, I don't know what this is. Okay, so this is the data, and this is the table below, and you can see 2 kind of strange things here. So one of them is that you can see that the ID, the city, the temperature, and the date all are varchar. Okay, and this is a bad practice. Okay, I don't want to get into that why it's a bad practice, but basically, just very shortly, the problem is that if you take date and save it as a character, there are lots of problems that this reflects. For example, I cannot do any calculation with dates. Order by will be a little bit messed up. The optimizer. And the same with numbers. Okay, so high temperature C, I would expect it to be a number and not a varchar. Okay, so there are performance issues here. There are some data integrity issues as well. So that's one. The second one that I started saying a little bit before is this. I set the temperature, date, and the temperature itself for Vancouver and Tashkent. But when you look at Tel Aviv, you see that 1st of January, 9999, and the temperature is 9999, which doesn't make any sense, right? So I've seen cases where developers take values like that for invalid values, okay, or irrelevant values or something like that, and with them represent not available or not applicable values. Okay, so instead of having null as a value, or not a value, but null in the column when I don't have this data, they just put some invalid value, -1, or some unreasonable date or unreasonable date or something like that. And this is a problem as well, because this messes up the statistics of the optimizer, and it brings all kind of weird stuff. Okay, so first of all, when you design your columns and data, you need to think about that. What data types should I use? And you should use the correct data types as much as possible. What values do I put in the database? If something is not available, do I write there null? Do I leave it blank? Do I put, I don't know, space? Anything like that. You need to make sure that you do your design of these pieces, as well as designing the tables and indexes and the rest, because this will affect your application. Okay, so let's move on. Another example that I've seen with columns and data is this. I have a table and I have ID with some information, and then I have year, month, and day. And like I showed you in the previous slide, everything is varchar, and varchar is problematic for this data. We talked about that, but let's leave that aside for now. But let's look at the values inside this table. And again, this was a real example. When I look at that, and when you look at that, I hope you expect to see the year 2021, the month is, I don't know, October or 10 or whatever, and the day is 21, which is today for you, 20 for me. But the data that I actually saw was that. So ID 1, the year was 2020, month was 2020-1, and then the day 2020-1-1. And the problem with this is that, first of all, it's redundant, right? We have data that repeats itself, which doesn't make any sense. What I had as a problem here specifically, and that was a while ago, today it wouldn't happen as much, but still, is that the optimizer was completely confused about this thing, okay? Because the queries used year equals 2020, month equal 2020-01, and the day equals 2020-01-01. And I don't want to get into the details of why it messed up the optimizer, but it did, because the estimation of the optimizer were completely messed up because the data is redundant. Because basically, if you had only day equals 2020-01-01, you had all the information you need. You don't need the month, you don't need the year. Okay, so make sure these things don't happen in your system. It's either year 2020, month 01, day 01, or just keep the day and have the full day and that's it, or something like that. Okay, this doesn't make sense and it causes problems. Next, indexes. So indexes is probably today the least problematic topic, because in Oracle, at least, most of the things you can do online without any locking, without any problems. You can create invisible indexes. You can create all different kind of things online on a production system without affecting too much, without affecting the system or the users too much. Okay, but when you plan a new system, it is something that you need to think about, and you need to decide which index type you want, B-tree or bitmap, and it depends on your requirements. Again, bitmap is good for certain things, B-tree is good for different things. It has different locking issues and all of that. You can have a composite index, an index on more than one column, and the order is very important here. So you need to decide which column is the first and which is the second or third, based on your application, based on your queries. You can also create function-based index in some cases if you need them. How many indexes? That's a good question. I've seen systems that say, yeah, you know what, we give complete flexibility to our users, and they can query anything, anytime. So we just created a lot of indexes on pretty much everything, which is good maybe for queries, but it has some overhead with DMLs and changes to the data. So again, this is a balance that you need to decide eventually how many indexes and what type. And with Autonomous DB, we see that Oracle goes more and more into Autonomous DB, and there is a feature called automatic indexes, which means that the system itself realizes what queries you are executing and creates indexes based on that. So maybe sometimes in the future, we won't need to deal with that anymore, and Oracle will do anything for us. I doubt it, I have to say. It might take quite some time until this is completely, automated and working well. But for now, this is starting, okay? And again, even when the system is up, we can drop indexes, we can create new ones without affecting the system too much. So indexes is something that we need to think about, we need to consider, we need to decide, but we can. It will be easier to change the decision over time. The next thing that I want to mention is table normalization. And I don't know if you know what it means or not, but I just want to, get everyone to the same level, so we'll understand the concept of all the details. I didn't say that before, but the presentation is divided into two pieces. The first one is just an overview about all kinds of different aspects of schema design, and the second half is actually designing a schema. So we'll see all kinds of different ways to do that. So we'll use table normalization there as well. Okay, so table normalization, we have a table with employees. So we have the employee ID, name, department, city, and state. And the concept of normalization is basically take entities from the database and split them into different tables. So in this case, we have a department, we have IT and sales, and instead of having them in the employee table itself, we can take and split that into a new table called departments, okay? And save the department ID only in the employee table, and then have the department ID and the name in the department table. And the benefit of that is that we can have more information about departments as well. We can have the department manager, the location, or any other things that we might want to add to departments without just adding more and more column to the main employees table. And the same we can do with the city and state. We can take this, the city, split it into a cities table and have the city and the state. We can do the same with state, or we can do all kinds of different things to separate that into different tables. And one thing that is very important about normalization is changing data. Okay, so this is a real case in California. In 1992, they decided to change the name of the city from Grover City to Grover Beach. And think about the employee table from the previous slide. What happened if we had 1,000 people lived in Grover City? Okay, so if we had the table, if we had the city information in the employees table, we had to run update number 1, which is update employees, set city Grover Beach, where city is Grover City, and state is California. And that will update 1,000 rows, right? And the problem here that it's sometimes a lot of work, depend on how many rows we are updating. Locking issues, okay? Some standardization. Okay, some people can write Grover Beach with capital G, capital B. Some will put hyphen in the middle. You know, non-standard option. Like there is no standard way to have the name. The second update is if I split that into the cities table, and with the cities table, I'm updating the cities where city is Grover City and state is California into Grover Beach. But here I have this only once. So I'm not touching the employee table, no locking, no problem. I have complete standard way to say that because I have the name of the city only once. And it doesn't matter how many employees live here. I just change it once and that's it. Okay, so that's a benefit of normalization, but in some cases we don't want normalization, and we're going to mention that in a little while. Okay, and the last thing is constraints and triggers. Okay, so the concept of constraints and triggers is to enforce mainly data integrity. Okay, so we can force data types and values. For example, if we have a date, we can say, okay, the date has to be between in 2020 or 2021. You cannot enter any date you want. Enforce parent-child relations. For example, city and employee. I cannot insert employee with a city that doesn't exist. Okay, so that's a parent-child relations. Uniqueness, if I have something that is unique, like I don't know, plate number on cars or something like that. Not null if I don't allow some columns to have null values. And for complex scenarios, you can have triggers. Okay, now triggers is more overhead and it's sometimes a bit difficult to handle, but in some cases, these are the best way to keep data integrity. So let's look at a very simplified example, and we'll compare OLTP system, online transaction processing system, to data warehouse, okay? And this is a very simplified example. Usually systems are not pure OLTP or pure data warehouse, but we'll take that just as an example to see how the application itself affects the design that we're going to use. Okay, so with OLTP, usually we want to avoid duplicates. And that will save space. In data warehouse, we usually allow duplicates, but compress the tables, okay? For data integrity, OLTP is more important because if OLTP are systems where people change the data all the time. They take one row, they change it, they update it all the time, they insert new rows and so on and so forth. I want the data integrity to be intact. I need everything to be perfect. Otherwise, it's a mess. In data warehouse, usually in a classical data warehouse systems, we have one system and it takes data from other systems, okay? And it's usually we insert once and we query many times for reporting, for, I don't know, data analysis and stuff like that, okay? So the data integrity is much less important because we can validate the data. First of all, it comes from different systems. So if the data is validated there, maybe that's enough. But even if not, we take the data from other system and we load it once. No updates will be performed on this data. So actually, we can validate the data when it comes in, and because it never changes, we don't have to have triggers or constraints or anything like that to keep the data integrity. It won't change. The data integrity will be kept, okay? Normalization. In OLTP, we will want to normalize as much as possible. We saw the cities table, the department table. These are things that I want to see in OLTP systems. In data warehouse, it's the other way around. I will want to denormalize because long reports, I don't want to join all this bunch of tables. I prefer to denormalize some of the data and query less tables and get better performance, even though it will take more space and it will have some problems like the data integrity and stuff like that. But again, data warehouse, I'm not necessarily concerned about that. Contention. Contention is concurrent access or concurrent operations on the same pieces of data in the disk or in memory. And in OLTP, we would like to avoid that, because in OLTP, many people will be able to get to this data and query it and change it maybe. So we want to avoid locking, because locking is a problem in OLTP, and we want to avoid contention, which might lead to performance issues. In data warehouse, it's pretty much irrelevant, because we have a few processes that load the system. All the rest are just querying, so it's much less of a problem. And performance, instant response versus reports. When you log into your bank account and you click something, you want the data to come back instantly. When people work on data warehouse and generate huge report for, I don't know, the entire year of 2020, if it takes 10 minutes, it takes 10 minutes. If it takes overnight, that's not a problem, right? So that was just an example. Again, in real life, it's much more complicated than that. But I just wanted to show you how all the things we talked about data integrity, we talked about normalization, we talked about performance, how these are different between different systems. And if the systems are different, the requirements are different, the database design that we will do is different. Okay, and that was the point of that. So let's move on. We don't have a lot of people, but I do have a poll. Maybe I'll try to do that. So at the end of this slide, I'll look for the poll and I run it. Okay, so let's design a schema. This is the second part of the presentation, and let's see what you say, and let's see what the options are. So we have a requirement in front of us from a company called Books and More, and we need to build the software for them. And Books and More, they have three types of products in their store. One is books, the other one is magazines, and the last one is audio CD. Okay, and each and every product has some attributes. Okay, 5 attributes each. And if you pay attention, you see that 3 attributes are common. So each product has title, date, and price. But books have author and number of pages, magazines have publication and frequency, and audio CD has a musician and number of tracks. Okay, so this is the requirement. If we don't take into account lookup tables, and lookup tables, I mean like author, I have the number of the author and table of authors. Okay, if we just ignore these lookup tables that just number to a name, or like translation tables, and we just put the author inside the book, denormalize. Okay, so the author is just the name of the author, the publication is the name of the publication, musician is the same. But you have these 3 products. How many tables would you use in order to represent this application? Okay, so again, we don't have many people in, but let's try this. Where is my mouse? Okay, let's start the poll. How many tables? Okay. Awesome. So take a few seconds and just say, how many tables would you use for that? 1 table, 2, 3, 4, 5, more than that? Okay. Anyone else? Oh, that's funny. Okay. We'll give you another 5 seconds. 3, 2, 1. That's it? Okay. So again, we don't have many people, but we have 3 people answering, and all 3 said 3 tables, which is very interesting. Okay, so I assume 1 for books, 1 for magazines, and 1 for CDs. Oh, I'll share the results. So as you can see, 3 people answered, and all of them said 3 tables. Okay. Yeah, someone on the chat says 3 tables as well. Awesome, that's unanimous. So all of you chose the same answer, which is cool. Usually that's not happening. Okay, so what I want to do now for the next, I don't know, about 20 minutes probably, and then leave some time for questions, is to go over all kinds of different ways to do that and analyze the benefits and the downsides of each solution. Okay, so you said 3 tables, we'll get to that. But we'll start with 1 table. Oh, Rustam said more than 5. That's interesting. I've never seen more than 5. I actually don't have one with 5 even. I have 1, 2, 3, and 4, and we'll see that. If you want to share your 5-table solution, that would be nice at the end. So let's start with 1 table. Okay, and just to explain the coloring here, what I did basically in most of the examples here, the white blank columns are the shared one, the common one, the ones that every product has. And then I have the two red columns with the B in parentheses. These are for books, B is books. The M, publication and frequency in bluish color, is the magazines, and the musician number of tracks in yellow, or the A in parentheses, is the audio CD. Okay, so 1 single table, I call it one big happy table. It's 1 table that has all the columns. Okay, so if I have a book, the book will have ID, type, which is a book, title, date, price, which are the common columns, and then it will have author, it will have number of pages, and the rest, the publication, frequency, musician, and number of tracks, will be null. And if I insert the audio CD, it will have ID, type, title, date, and price, like everyone else, but it will have the author, number of pages, publication, and frequency null, and the musician and number of tracks will have values. So basically, I have 1 table with all the data, while by definition, some of the columns will be null for each row. Depends on the type. Okay? So that's the easiest solution that there is, right? And let's see why and why not use something like that. So first of all, it's very simple. Okay? Anybody can understand that. It also provides very good performance. Why? Because we don't need to join anything. All the data is in 1 block in 1 table. So if I want to access a specific magazine, I will query it. I will use an index potentially, get to the row, and once I have the row, that's it. I have all the information I need. Okay? I don't need to join anything. I don't need to look up in other tables. I don't need to do anything. Why not using this option? First of all, contention. Okay, for OLTP, contention is a problem. Contention is when multiple users want to access or change the same data. And here we have everything in 1 table, meaning that if someone by accident locks a big chunk of the table, it affects other people. Also, everything is in the same blocks of the table. So if many people go and access the same blocks, that contention at the memory level, and basically it's not great for OLTP. In OLTP, I would like to spread the load across the physical disk and spread the load across the memory, okay? And here it happens less. Also, if I want to change anything or I have a problem with the table, that's a full downtime, right? Once something happens to this specific table, everything is down. And the last thing, unnecessary scan of irrelevant data. If I want to query all the books in the system, probably Oracle will just perform a full table scan on this table. And with the full table scan on this table, I will also scan audio CDs and magazines, which I don't need. So there's no point in scanning them. It will just take longer, and I don't need to do that, right? So that's the downsides of this design. So if this is the case, let's see the next option. And the next option is the one that you chose the most. And that's 3 tables. So let's have like 3 tables, one for books, one for magazines, one for audio. Each table will have the 5 common columns and the 2 special columns for this specific type. So books will have only author and number of pages, magazine will have only publication and frequency, audio will have only musician and number of tracks, which makes sense, right? So let's see what the benefit and the downsides of this design. First of all, it's simple. Again, very easy to understand, very simple to implement. It's also pretty good performance. Again, if we want a specific book, we'll go to the book, everything is there. We don't need to access any other tables, any other blocks. Everything is right there in the same block, the same row. We have all the information, so it's a good performance. We also access only relevant product. Okay, so if I want to check something about books only, I go to the books table. Unlike the one big happy table, which I accessed all the products. Okay, so in this case, that's a benefit. If I want to access or query one specific product, I go to the relevant table. Changing structure of one product doesn't affect others. If I have a problem with one of the tables, let's say books, or I want to do some maintenance on the books table, audio CD and the magazines are intact. They can be operational as usual. Now, I didn't say that before. Obviously, this is a very, very, very super simplified example, but I'm sure that you can implement these concepts into your system. And when I say that's only one table or 2 tables, obviously in real life scenario, it won't be 1 or 2 tables, it can be 5 or 6, but 5 or 6 compared to 20, it's a huge difference. Like here, 1 table compared to 3 is a huge difference. Okay, so I'm very simplifying everything, but you can take it into your real case scenarios and understand what I mean. Okay, so this is changing the structure. If I need to change one part of the application, I don't touch the other ones. I have less null columns. So why is it a benefit? It's not bad to have null columns. So the thing here is a few things. First of all, nulls, even though they are null and they don't mean anything, it's no value at all, in some cases, they do consume a little bit of space. Okay, if they are in the middle of the row, they consume a little bit of space. If they are at the end of the row, they don't. So they consume a little bit of space. So if you have lots of columns that are null, you might see that as a space consuming thing as well, but it's not a lot, so it's not a big problem. The bigger problem is that Oracle has some, it's not really a limitation, but you'll see performance degradation and some problems with very, very wide tables. I don't remember the exact number, but if you know Jonathan Lewis, you can look for his blog, Scratchpad, I think it's called, and look for very wide tables and performance issues. He's a performance guru if you don't know him. And I think he mentioned something about 255 or something like that number of columns in one table. So if by definition you say, okay, I need to add more columns to some product, and you just create one huge table with lots of columns, once you hit a certain number, and it's a big number, but still, once you hit that, you will start to see some performance issues and some other problems. So you need to be aware of that. If we're talking about 10 columns, that's not a problem. If we're talking about 300, it might be. Okay, so it might be better to split that into different tables, and these 3-table solution solves that. So where are the downsides? If I want to add another product, when I want to add another product for that, I'm going back one, I need to create a new table and to have a name. Let's say, I don't know, pens, okay? So I need to create a table with pens, and then I need to change my application so it will query the pens table with all of that with all of its specific, columns and everything. Okay, so every addition of something is a major change. I need to create some new objects in the database. I need to change my application. It's not completely flexible. Okay, so flexibility is a little bit of an issue here. Also, querying all products. I want to know how many products I have, or how many products I have in the store that cost less than $10. To do that here in this design requires to go to 3 tables. And again, if I add the pens table, I need to change the code in the application to access the 4th table as well. And obviously I can create a view that combine all of these 3 or 4 tables, but then I need to remember to maintain the view every time I change something, right? So this is somewhat a downside. Or if I have the last thing here, if I have an object, I know the title of the object, but I'm not sure if it's a book or a magazine. I will need to go and look in both to figure that out, right? So these are some downsides for the 3-table solution. So let's see another table, another solution, and that's the 4-table one. So here we have 4 tables in general. One, I call that items, and it contains only the 5 common columns, okay? The ID, type, title, date, and price. And then I have 3 more tables for each product. One for books, which has ID and foreign key and relation, parent-child relation to the items table, and audio are the same, and magazines are the same. Okay, so here I'm actually using the relational database management system, RDBMS, and I create tables that have relationship to the items table. Okay, so this is the 4-table solution. And the benefit of the 4-table solution is that it's the classic RDBMS design. We have the common columns in one table and the unique columns in other tables, and we have relationship between them. Now, this is very simple to summarize common properties. So for example, or search for an item with unknown type. Because I have, I'm going back one, because I have one table that contains all the common columns on the left, the items, it's very easy to say, okay, how many items do I have that cost less than $10? Or I have a title of a product. I want to see which items I have with this title, okay? In this case, unlike the 3 tables, which I had to look at each table separately, here I just check the items table. Once I found the row, I can go and get the rest of the data if I need from the relevant table, the books, audio, or magazine. Okay, I see that there is a question here, so I'll just finish this 4-table solution and I'll read the question. So these are the benefits. The downsides: queries require more joins. Now, we are working with database and SQL, so queries and joins is not really a problem. Why is this a downside? So again, in this case, it's not really a downside. That's a very classical solution, 2 tables in a join, or even a little bit more, that's fine. But if you take a much more complex scenario and you try to split that into lots and lots and lots of tables, you sometimes end with queries that have like 20 or 30 tables in a join. And this is where things are getting messy. Okay, analyzing performance for so many tables is a tricky thing. It's a lot of work for the optimizer. Okay, so you need to know that joins are great. That's at the heart of the RDBMS, but it comes with a cost. So be aware that if you start splitting that into gazillion tables and you need to join all of them for query, it might be a problem. And the last thing, adding another product. Again, if I want to add another product, I need to create a new table with a relation. I need to change my application. Flexibility is not the best here. Okay, so this was a 4-table solution, and I have 2 more solutions. Just a second, sorry. Okay. Okay, so let's move to the next. It wasn't a question in the chat. Okay, so let's move to the next solution. So the two-table solution. Two-table solution is completely different than anything we've seen until now. Okay, so in the two-table solution, I'm going to go for a completely different approach. I have the items table with the common properties, ID, type, title, date, and price. And then I have the properties table, which has the ID of the item and property name and property value. And that's it. And it will look, the table will look something like that. Okay, for ID 1, I hope you can see. Now you can see okay, I hope you can see my cursor here. So ID number 1, I have 2 rows here in the properties table. The first row is author, property. The property name is author, and the property value is Stephen King. And the second row, number of pages, is 7,000. And if you read books by Stephen King, you know that this is a roughly estimation, a good estimation of the number of pages he's writing. Okay. And then another product, number 2, is a musician, Pink. So basically, each property, all of the unique or special columns or attributes that I have will be in this table as a row. Okay, author, Stephen King, number of pages, 7,000. And then musician, Pink, and so on and so forth for each product. Okay. Why to use that? That provides amazing flexibility. Okay. You can do basically whatever you want. If you want to add new column, you can just do that. You don't need to change the structure of anything in the database. You want to add another product, you want to add another column, I said, add another product or anything else in the structure, you can just change on the fly because the entire structure is basically the values, the rows, the data in the properties table. So everything is completely flexible. The downside, enforcing constraints is practically impossible. Okay, and data types as well. So think about that. Here, the property value. Where's my mouse? The properties value. This one, the Stephen King is text, but the 7,000 is a number, right? So I've seen some people that they add property value text, property value number, property value date. And that's possible, but it makes things even more complex. Okay, so that's the data type constraints. I cannot enforce. I cannot make sure that the number of pages, for example, is a positive number. Okay, it's practically impossible. And also querying that is really difficult. And let's see. I don't have a lot of time. It took a little bit longer than I expected. So let's go through that quickly. I have another example, and I think that would be it. Okay, so query a specific author is relatively okay. Select star from items where type is book, and the ID is select ID from the properties table where property name is author and property value is Stephen King. So the inner query will get me the IDs of the books that have author Stephen King, and then I can get these IDs and go to the items table to get the rest. That's nice. If I want a specific author or number of pages, that's a little bit tricky. I cannot use or because these are 2 different rows in the properties table. So I would just query all the rows from the properties table that are either author or number of pages. Okay, so select ID from the properties table where property name and property values are author Stephen King or number of pages 7,000. In this case, I will get all the IDs of books that have either author Stephen King or number of pages 7,000. And with these IDs, I go to the items table and get the books. So far, so good, relatively. Where it really gets messed up is when I want to query author and number of pages, because I can't do and. Okay, these are two different rows in the properties table. So basically what I did here is I queried like before, give me all the IDs from the properties table where it's author Stephen King or number of pages 7,000. But then I check how many times I see this ID. And if I do group by having count star 2, meaning that the same ID got a row for author Stephen King and another row for number of pages 7,000, which is basically this and this, okay? And this is only something and something. Think about more complex, something and something or something else. I don't know. This is getting crazy, okay? And I've seen this happening in real life, and it's not pretty, but it's very flexible. Okay. The last example would be one table, but a different one. And this is it. So I have one table, I call it all items, and I have the common columns, ID type, title, date, and price, and then just add other info, which is a JSON. And that's it. And in the JSON, I'll have either author and number of pages for books, or publication and whatever for magazines, and musician for audio, and so on. Okay, so just all the unique columns, all the specific columns per product, I will just have in a JSON, which developers love, by the way. So the benefits is developers love that. So it's really easy for them to handle, because everything is JSON today, and they just read the JSON and they analyze it, and everything is very cool. The second benefit is that it's extremely flexible. Again, JSON by definition is very flexible. So this one is extremely flexible as well. But the downside, it's not really relational database management system. Okay, it's not the concept of RDBMS. And this means that we cannot force anything by definition, because JSON is very flexible and it can change and it's not structured. So it's really difficult to enforce stuff. And querying is a little bit tricky as well, even though there are solutions for that in the new versions. So we can do that, but then we lose some of the options of the benefits of relational database system. Okay, and just to show you how query would look like, that's relatively easy. Because of the support of JSON in Oracle, we just use where type equals book and other info dot author equals Stephen King, and Oracle can parse the JSON and get the information. We can also create indexes on that, and that's awesome. So JSON is supported pretty well in Oracle, but still we do lose constraints. We do lose some of the concepts of a relational database. So to conclude that, which one is the best? And the answer is, it depends. And it depends on the performance and the flexibility and the data integrity and the querying and the space that you need or require from your application. If you need more flexibility, you can go for the two-table solution. If you want to be more strict, you can go to the other solutions. Data integrity, you won't go to the two-table solutions, because the data integrity there is really hell to handle, okay? Or the JSON one. You'll go with the more classical one-table, three-table, four-table options. Querying depends on your needs. You want to query many times objects or products from all tables. Maybe one table or four table is a better solution than the three table. Okay, so what I wanted to show you here is that when you come and create, when you need to create a design for a new application or new part of existing application, there are many ways. There is no right way to do something. Okay, each way or each design have benefits and downsides. So you need to think about your specific requirements and your specific needs and your specific application, and then plan based on these concepts. Plan the design or design the database to fit the needs you have in your application. And if we have time, but we don't, so you can see that in the presentation by yourself, and this is it. So if you have questions, I'm here. If you want to, again, contact me, I have the contact information here as well. And thank you for joining. And I hope you have a great day and a great conference. So let's see if you have questions. Yeah, there is a question about indexes in JSON. So I don't remember all the information, but I know that you can index JSON columns. Okay, you can index, basically you can index pieces of JSON. If you know the attributes inside the JSON, there is a way, I don't remember the syntax, but there is a way to create index on the JSON attributes as well. So actually this piece is solved. But you know, you can look for the specific syntax, but it is possible. Okay. Any other questions? No? Okay.
Thank you, Liron, for this amazing presentation with bringing us the liveful and very easy to understand examples. And I hope that was very interesting. And still we have got some 1 minute, I guess, for the question. If there is question from the participants, they can ask. Or if not, there's a question. Okay, Behruz, it will be the last question, I guess.
And Sandesh,
come on, you guys, take advantage of the, you've got such a good speaker out here who's going into this topic. Please take advantage and ask questions, right? In this virtual world we live in, this is our only forum and opportunity to learn as much as we can. And it's very hard to get speakers like Liron to kind of dedicate his time and energy to do these kind of things. So if you have an opportunity, if you have a question that's been burning in your thing, just go for it and ask. It's okay, time is time.
Thank you, Sandesh, for understanding.
Yeah, Sandesh, I see you saw my Twitter and my tweet, and you just want me to spend all your time.
I love the concept of a community, right? It's like, it's not about like, hey, it's your session is 1 hour and my session is 1 hour. If we are having a good time discussing and having a conversation that everybody's learning, I think the purpose of this forum is served, right? That's what this whole Central Asia Oracle user group is all about, is everybody learning. And if they learn more from you as compared to learning from me, I don't have a problem with that.
I doubt it, but thanks.
No, I really don't.
Yeah, but I completely agree. Yeah, the community,
I have a good time. I learn
that's the entire thing of the community. And one of the things that I miss the most in conferences, like being online, is the fact that once you finish the presentation, usually people come and you talk to them and you go out of the room and you walk outside and you meet new people and you talk about all kinds of different stuff. I think this piece is lost in online conferences.
Very soon, my friend. Very, very soon. I think I've already seen the first, I think the Swiss Oracle user group already started in person. Then I saw even HRO had something in person. The Polish one also had something in person.
They were the first one, and then Croatia. Yeah.
Yes.
Yeah. So Europe is starting to open.
I'm optimistic that even in the US, all these things are going to start very soon. So
yeah. Okay. So just quick answer to the question, and then I'll give you the microphone, Sandesh. Was the 3-table solution normalized? So I switched to this. Sort of. There are, there is a theory model about normalization. There are different ways to normalize tables. So yeah, this is more normalized than the first one. There are different levels. I don't really want to get to the theory of that. But it's sort of, it's a little bit normalized, more normalized than the 1 table, that's for sure. Okay. Okay, so thank you again.
Do people still use the Boy Scout normal form, or is that a dead art now?
I have to admit that I don't use this like 3NF, BCNF, all of this. I don't use it formally, but
Okay.
yeah, I think people at least in the higher education, I think they do study about that and use that.
Cool.